Morning 12th standard students, we are going to learn physics first chapter. In that we are going to define centripetal force, the force which is acting on a particle performing uniform circular motion towards the center of the circle and along the radius is called as centripetal force. Centripetal force is equal to mass into centripetal acceleration. Therefore, centripetal force is equal to m into v square divided by r. Therefore, F is equal to m into v square divided by r, or in term of angular velocity we write it as F is equal to mr omega square. After then we are going to study centrifugal force, the force which is acting on a particle in uniform circular motion directed away from center of the circle along the radius is called as centrifugal force. Centrifugal force is also called as an imaginary force or pseudo force. Centrifugal force is equal to mass into centrifugal acceleration, and that is equal to m into v square by r. Therefore, F is equal to m into r omega square. This is the magnitude relation of centrifugal force. Now, depending upon this, we are going to study the examples. Find the angular speed of the seconds hand of a clock. So t is equal to 60 seconds. The angular speed, that is omega, is equal to 2 pi divided by t, that is 2 into 3.14 upon 60. Further we simplify it as 1.047 into 10 raised to minus 1 radian per seconds. Now the second example is, what is the angular displacement of the minute's hand in 20 minutes? So therefore small t is equal to (20 minutes), and what is a question mark in front of angular displacement theta. But the formula of angular displacement theta is equal to omega into t, that is equal to 2 pi upon capital T into small t, and that is further equal to, put the value of t, small t, as 20. Therefore 2 pi divided by 60 into 20, that is, after simplification we get it as 2 pi upon 3 radian. Now here we are going to find the angular acceleration of a particle in circular motion which slows down from 600 revolutions per minute to rest in 10 seconds. This is the third example. Now see here, in this case the frequency is given as n1 initial frequency is as 600 revolution per minute, but we know the relation 1 minute is equal to 60 seconds. Therefore, first of all, we have to convert frequency from revolution per minute to revolutions per second. Therefore, 600 divided by 60 further is equal to 10 hertz. And here the small t is 10 seconds, and we have to calculate angular acceleration alpha. Therefore, in front of alpha a question mark. Now, the particle in circular motion is its speed is decreasing to 0, and therefore the frequency n2 is equal to 0 hertz. That is the final frequency. And we know the formula of angular acceleration alpha equal to omega 2 minus omega 1 divided by small t. Here further it is equal to 2 pi n2 minus 2 pi n1 divided by t, and further put the values of n1 and n2 into this formula, so that the step that alpha becomes is equal to 2 pi into 0 minus 2 pi into 10 divided by 10. Simplify it further as minus 2 pi into 10 divided by 10 get cancelled, and that is equal to minus 2 pi. Put the value of pi as 3.14. Therefore, alpha is equal to minus 6.28 radian per second square. And see here in this case, omega 2 is final angular velocity and omega 1 is initial angular velocity.